Good morning, boys and girls. This is your 7-2 practice problem video. This is the section on substitution, and I'm super excited about it because I love doing substitution and systems of equations. These problems are in your workbook on page 403, and you can't possibly do them in a smash like that, so you would need to do them probably on notebook paper. I'm going to do several of them for you just to give you an idea how to solve these, and then you'll be able to hop on over to McGraw-Hill and complete your practice assignment. Put this on pen. Let's go with blue today. I'm feeling blue today. Okay. For the most part, one or both of these equations will be solved for y. Okay. In number 1, you can see that the first equation is solved for y, and the second one's not. So what we're going to do is we're going to go ahead and we're going to take this 5x plus 1 and we're going to put it in for y right here. So we would have 4x plus 5x plus 1. Now, notice I didn't put this in parentheses. If, for example, this happened to be a minus sign, we would have to put this in parentheses and distribute the minus sign. But multiplying both of these by a positive 1 does nothing, so I kind of didn't need those parentheses here. Let's get rid of the parentheses. They don't do anything because it was a plus. All right. Now let's combine like terms. 9x plus 1 equals 10. And then you would solve for x, subtracting 1 from both sides, gives me 9x equals 9, which means x is 1. Now I take the fact that I know x is 1 and I substitute it into either one of these equations to find out what y is. I choose the first one because y is all by itself over there, so this is going to be fairly easy. Y equals 5 times 1, because I know x is 1 now, plus 1. Y equals 5 plus 1, so y is 6. So the solution to this system of equations has one solution, and it is the point 1, 6. Number 2 is the exact same thing. You're just going to substitute 4x plus 5 for the y. This is a plus, so nothing weird's going on. I'm going to skip over to number 3, though, because I certainly don't want to make a video of doing all of these. It would be way too long. You would be bored. When you have both equations solved for y, what you can do is you can set them equal to each other. If y is equal to this and y is also equal to this, then these two things have to equal each other. So I can do 3x minus 34 equals 2x minus 5. Now I want to get all my variables on one side, so I'll get rid of the smaller one, which is 2x. And that gives me x minus 34 equals negative 5. Then I want to add 34 to both sides. And that tells me that x is 29. Okay. Now I can substitute 29 for x in either one of these equations to find out what y is. I'll use y equals 2x minus 5. I'm going to substitute 29 for x. That gives me, is that 58 minus 5? So y is 53. So my coordinate point would be 29, 53. Wow, that is when you would not want to have to grade, or to graph. Okay, hang on just a second. Okay, so number 4, notice, can be solved exactly the same way we just solved number 3. Just do 3x minus 2 equals 2x minus 5, solve for x, then go back and substitute your x value to solve for y. Right? Now I'm going to start with number 5 because I notice here neither one of these is solved for y. So my first objective is going to be to solve one of them for y or x, as long as you can solve it for one variable or the other. For this one, I always want to zero in on the variable that does not have a coefficient. Okay, it's easier to isolate that one because you don't have that extra step of dividing everything by a certain number. So I'm going to go after this equation right here. 2x plus y equals 3 because it's very easy to solve this for one of the variables. By subtracting 2x from both sides, I have y equals negative 2x plus 3. So now instead of this equation, my system of equations, I have y equals negative 2x plus 3 is the second equation. Now I can substitute this quantity for y. So let's do 4x plus 4, and now in parentheses, I'm substituting the y value, this 2x minus negative 2x plus 3. Okay, and that is equal to 8. And there's a little more going on in this one now. I've got to use the distributive property. 4x, positive 4 times negative 2x is negative 8x. Positive 4 times positive 3 is positive 12 equals 8. Now I need to solve for x. First I'm going to combine like terms. This gives me negative 4x plus 12 equals 8. To get x by itself, I would subtract 12 from both sides. That gives me negative 4x equals negative 4, and that means x is 1. So I have my x now, I need my y. Well, I'm going to use the equation I created because it's simpler than this other one. Substituting 1 for x in this equation, I would have y equals negative 2 times 1 plus 3. So I have y equals negative 2 plus 3. So y is also 1. So the point that solves this system of equations is the point 1, 1. Now I kind of want to do the next one. I know I've been skipping the evens, but I want to do this one because in this one I'm going to solve for x. X doesn't have a coefficient, so that makes this one easier to solve for x. So to get x by itself, I'm going to subtract 2y from both sides. And now I have x equals negative 2y minus 1. I can take negative 2y minus 1 and put it in for this y here. So I have 3x plus 4 times negative 2y minus 1 equals negative 3. We're going to substitute to get rid of the parentheses. 3x, 4 times negative 2y is negative 8y. And 4 times negative 1 is negative 4. Uh-oh, I did something wrong. I substituted that for y, right? No, I substituted for y. Oh no, screw up. Okay, I hope you're doing this in pencil. I went ahead and substituted for y because I almost always substitute for y, and so I thought I'm substituting for y. Be careful, that's an easy mistake to make. I'm substituting this for x. Some of you are probably out there going, no, no, Miss Williamson, stop, you're doing it wrong. Thank you. I wish I could have heard you. Negative 2y minus 1. All right, so I went back up, and now I'm substituting for x like I was supposed to, equals negative 3. All right, now I use the distributive property to get rid of the parentheses. 3 times negative 2y is negative 6y. 3 times negative 1 is negative 3, plus 4y. And I was just going along going, wow, you have such nice handwriting anymore on this thing. And then I noticed that I had x's and y's in the same problem, and I was like, oh, this is not right. Combining like terms, let's combine a negative 6y with a positive 4y, which will give us a negative 2y minus 3 equals negative 3. Now we're going to add 3 to both sides. And that gives me negative 2y equals 0. If negative 2y is 0, that means y has to be 0. Okay? And 0 is a solution. Don't go saying, oh, no solution. No, 0 is a solution. It's a whole number. All right, so now I'm going to substitute y equals 0 into one of these equations to solve for x. Let's use the one I made. If I put a 0 here for y, don't we have x is negative 1? We do. So we'll have x equals negative 1. And the solution, you would type in negative 1 comma 0. Okay. Moving on. Let's see, number 7, they have solved for y. Number 8, they have not solved for a letter. And number 9 is one of those ones that is so simple, it's hard. So maybe we'll do 8 and 9. I don't want to do all of them. We'll be here all day. Let's do 8 and 9 on this page. Okay, number 8, I am going to have to solve for a variable because one has not been solved for. And I'm going to solve for this y. It doesn't have a coefficient. It does have a negative sign in front of it, which makes it a little more trouble, but it's still the easiest one to go after. So we're going to go with the negative 1 equals 2x minus y. All right, I want to get y by itself. So you know what I could do? I could add y to both sides and add 1 to both sides. Let's do that. Add y to both sides and add 1 to both sides, and I get 2x plus 1. There you go. I could have done this multiple steps, but this was the easiest, quickest way to do it. All right, now in this equation, I am substituting for y this time. I have 2x plus 1 that I'm going to put in for this y. So let me switch colors so you can tell I'm switching problems. That gives me 8x minus 4, and now I'm substituting for y, 2x plus 1 equals negative 4. Okay. I'm going to distribute. Negative 4 times 2 is negative 8x. Negative 4 times positive 1 is negative 4. Okay. 8x minus 8x is 0. Minus 4 equals negative 4. And you see what I've got here? I've got a true statement. If you get a true statement like that, you do not need to go any further, okay? This has infinite solutions, which means both of these equations are the same equation. And if I had maybe divided everything by 4 here, you would see it better. If I divide everything by 4, that gives me 2x minus y equals negative 1. Do you see the similarity here? If I subtract 2x, there's the 2x minus y, there's the negative 1, they're just on the opposite sides. They are the same equation. That's pretty cool, like that. Let's do number 9. It's so easy, it's hard, okay? We have x's solved for. We know x is equal to y minus 1. So I'm going to put y minus 1 here, but notice this has a negative sign. So we're going to have to be very careful about distributing that negative. Plus y equals negative 1. Okay, so I took this x out and I put y minus 1 in its place. And then the rest of the equation is here, the plus y equals negative 1. I have to distribute this. I have to treat this as a negative 1. Negative 1 times y is negative y. Negative 1 times negative 1 is positive 1. And then that's not part of the distribution. Okay. Negative y and positive y add together, give me 0, and I end up with 1 equals negative 1, which is a false statement. This is a situation where there are no solutions. If you get false, there are no solutions. Glad I chose to do those two. Okay. In every case, they've either solved for y or made it easy. Like see here in this one's fairly simple to solve for y. You would just have to subtract 3y from both sides. Let me make sure I don't do any more all or no solutions. 10, 11, and 12. Okay, so I want to pick 10 or 11. Let's do, doesn't really matter. Let's do 10. All right, so I'm going to substitute negative 4x plus 11 for y right here. So that gives me 3x plus negative 4x plus 11 equals 9. Now, because this is a positive, it doesn't change anything inside the parentheses, so the parentheses are no longer needed. We can just go with minus 4x plus 11 equals 9. 3x minus 4x is negative 1x plus 11 equals 9. And then we would subtract 11 from both sides. And that gives us negative x equals negative 2. So therefore, x is 2, because you would multiply both sides by negative 1. Now we know x is 2. Let's go ahead and solve for y. So I'm going to use this equation because y is by itself. That gives me y equals negative 4 times x, which we now know is 2, plus 11. Okay? So we have y equals negative 8 plus 11. So y equals 3. And your solution would be the 0.23. Okay. Yeah. What else do we have? I want to do a nasty one. Number 15 looks like a beast. Number 15 looks like a beast because there are coefficients on everything. All right. So, okay, maybe I'll do number 13 and number 15. That way you get 2 more examples. All right, here I need to get a variable by itself. Okay, I can solve for either this negative y or this negative x. It's your choice. There's no wrong answer here. Because this one's the lower one, I'm going to go for this one, and I'm just going to subtract negative 3 or subtract 3y from both sides. That gives me negative x equals negative 3y plus 13. So I would have to multiply everything times the negative 1 to get x positive. That would give me positive 3y and minus 13. So this is going to be the equation I'm going to use. This one and this one. Okay. So now I have x solved for. I'm going to substitute. I'm going to put 3y minus 13 in for this x. First, I want to change colors. Might as well use colors if I have them. 5 times 3y minus 13 minus y equals 5. This can get kind of confusing. I took this x out and I put 3y minus 13 in its place. All right, and then all the rest of the equation is the same. Now I have to distribute. 5 times 3y is 15y. 5 times 13 is, well, 5 times 3 is 15, carrier 1, 65. Minus y equals 5. Okay. Combining like terms, 15y minus y is 14y. Minus 65 equals 5. And now I would add 65 to both sides. And that gives us 14y is equal to 70, which 13 is 5. Divide both sides by 14, and we get y is 5. Okay. Now I go back up and I substitute 5 for y. Let's use the equation we made. X equals 3 times 5, which we know is y now, minus 13. X is equal to 15 minus 13, so x is equal to 2. Once you have the x and the y, you're ready to write your solution point. The solution point is 2, 5. And number 15, I think, will be my last example of just these regular, double equations. I got to leave some for you guys to do. I have to solve for one of these, and I need to get a variable by itself, and every variable has a coefficient, so none of them are particularly friendly. I'm going to take this first equation, this negative 5x plus 4y equals 20, and I'm going to solve for the y because it happens to be positive, all right? First step would be to add 5x to both sides. That gives me 4y equals 5x plus 20. And then I'm going to divide every term by 4. Oh, this is nasty. Oh, I don't like that slope. I hope I haven't chosen poorly. Gives me 5/4 x plus 5. Okay. And then I have the equation 10x plus, why'd they put plus negative 8y? Oh, that was stupid. Equals negative 40. They're just trying to make this complicated. This should have been 10x minus 8y equals negative 40. That's better. Now this is what I'm going to substitute for y. Okay, so I have 10x minus 8 times 5/4 y plus 5 equals -40. I'm distributing the 8, 10x. -8 times this would give me -10. What did I do? I substituted for y, right? Oh, I see what I did. Another careless error. This is an x. Carelessness. Okay, I was like, what the heck? -10x minus 40. So it's going to be so much better when you guys are all in class because you can catch me and then I won't go too far with this. This is interesting how this is working out. 10x minus 10x is 0, and -40 is very much equal to -40. So we get a true statement, and that means that this one has infinite solutions. Okay. Alrighty, I think I want to just show you one word problem. I'm not going to test you on the word problems in this section, but I did want to share this one with you. You never know what's going to show up on the air test. Give me 1 second here real quick, though. Okay, I just wanted to let you know that on the actual McGraw-Hill site, if the solution is a point, then it's got 2 boxes. It's got parentheses and a comma in between, and then there's the first box where you type in the x value and the second box where you type in the y value. If it has infinite solutions or no solutions, it's a drop-down box where you have to choose infinite or no. Okay, so it should make it fairly easy for you. All right, this word problem here I found kind of interesting. I love it when you have $1 bills and $5 bills, and we know it adds up to this. You can totally guess and check one of these, but let me show you how you would solve this with the systems of equations. We know that Harvey has some $1 bills and some $5 bills. In all, he has 6 bills that are worth $22. Let x be the number of $1 bills and let y be the number of $5 bills. Write a system of equations to represent the information and use substitution to determine how many bills of each denomination Harry has. So they've defined our variables for us. They said x is $1 bills and y is $5 bills. It almost doesn't seem like there's enough information to make 2 equations, but let's read it again. We know he has some 1s and some 5s, okay? All in all, he has 6 bills that are worth $22, okay? So he has some number of one, he has one, the x's are worth 1, okay? So we're going to multiply 1 times however many $1 bills he has, okay? Plus, we know that the y's are worth 5 each, and y represents the number of $5 bills, okay? So if he has so many $1 bills and so many $5 bills, and it adds up to $22, that's one equation, okay? The other thing we know is that he has 6 bills, all right? So we know if you take the number of x bills and add it to the number of y bills, you get 6, okay? A lot of times you'll see problems like this with ages too, like Joey is 2 years older than his brother and Sally is 3 years younger than the other one, you know, stuff like that. But in this case, we have money. And these are the 2 things we know. We have some number of $1 bills, they're worth $1 each. Some number of $5 bills, they're worth $5 each. And when you add them all together, you get $22. And we know that he has 6 bills total, so if you add the number of $1 bills to the number of $5 bills, you get 6. All right, so this is going to be very easy to solve for one or the other. Let's just subtract x from both sides. That gives me y equals 6 minus x. I can use this equation and substitute 6 minus x for y. So I'm going to have 1x plus 5 times 6 minus x equals 22. Distribute. That gives me 30 minus 5x equals 22. Combine like terms. This gives me 30 minus 4x equals 22. Subtract 30 from both sides. This gives me negative 4x is equal to -8, and divide both sides by -4, and we get that x is 2. So we know that he has 2 $1 bills. So if we put 2 here for x, how many $5 bills does he have? He must have 4 $5 bills. So y must be 4. Okay? And so the answer would be, does this work out? If you have 2 $1 bills, all right, so this would be 2, and 4 of these, this would be 20. 20 plus 2 is 22. So we feel pretty good about our answer. He has 2 $1 bills and 4 $5 bills. Okay. Like I said, I didn't assign a word problem to you, but I wanted to show you how you could create one using systems of equations. So, all right, well, that's it. Go on over to McGraw-Hill and work on the practice assignment. Some of the problems I will have done for you. Some of the problems will be on the quiz. You know how that is. And if you have any questions, let me know, of course. Have a great day.